2 and 1. All right, let's begin. So this is part 1, so some probability examples. First example, what has higher probability when tossing a coin 4 times? Heads, 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 and heads, or flipping it 4 times and receiving heads, tails, heads, tails. So this is interesting because a lot of people think that the higher probability for this is this, instead of thinking that it might be this. Well, let's take a look and see what the answer is. The answer is they're equally likely. Okay, and this is why. So if you're going to flip a coin, so here is, let's imagine that we have a coin. So here's my coin. Let's make 4 flips. So I'm going to duplicate this. So let's say first flip, second flip, third flip, and then fourth flip. So what is, okay, so if we take a look here, I'm going to write these ones. So heads, 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 and heads. What's the probability of that? Well, the probability is, okay, so if you're flipping a coin, it's basically 50% chance to receive heads, right? So you flip it once. That's your probability. Now, to receive heads again, you're going to have 50% chance to flip head again. And then you're going to have a 50% chance and then 50% chance. So these, because they are independent of each other, so you're going to multiply the probabilities, and you're going to find that your probability is 1 over, and then 2, that's 2 to the power of 4 there in the denominator. So that's going to be 16. So that's the probability of actually flipping your coin 4 times and then receiving heads on all of them. So it's not very likely, but as you can see, it's exactly the same as the next one. Because if now, all right, so let me copy this down, duplicate it, and put it down in here. So if you have heads in here, so heads, heads, and heads, and heads, now you try to flip it 4 times again, and now you receive, so there's heads, tails, heads, tails. So notice heads, tails, which seems like it's, 50% chance for heads or tails, so this should be more likely. Well, but if you want this, okay, to get a head on your first flip, you're going to need, okay, you have a 50% chance of doing that. If you flip it again, okay, and you want a tail, you also have a 50% chance. Okay, here a head is going to be a 50% chance, and then here a tail is 50% chance. So you notice that these two things are identical. All right, so you have to be mindful of how you're going to be answering these types of questions. Both of these are actually equal. All right, so that answers your question number 1. So let's take a look at now question number 2. So for question number 2, it says, what is the probability of pulling a king, then a queen, then another queen? Now assume you are replacing your deck each time and reshuffling. So you have to know a little bit about cards and how many cards you have in a deck. So we'll assume that this is a standard deck, which is 52 cards. So at least that's what they tell us. So what that means is, okay, and again, so for those in terms of decks, so what you have aces, you have 4 aces. You have 2s, you have 4 2s, and then 4 3s, 4 4s, 4 5s, and all the way up to 10. Okay, so you have 4 10s, and then you have jacks, queens, and kings. So there's basically 4 of each, and that's why it makes it 52 cards in total. Now here it says we are replacing the deck. So that means if you're going to pull a card out, all right, then afterwards you put it back in, you reshuffle, and then you pull out another card. Okay, so that's what we have. So here is, if we have a deck of cards, so let's say if this is my deck of cards that I have, all right, and now what I'm going to do is I'm going to be pulling a card. So I have one card that I'm going to take out of here. And the first card, okay, I want to see is, all right, so let me see if it's going to be a king. So what's the probability of pulling up a king? Well, in total, I have 52 cards, and there are 4 kings. So my probability on the first, okay, pull to get a king is basically 4 out of 52. That's what I have. Now, what I'm doing is I'm going to take that card and then put it back in because I am replacing, and then I'm going to shuffle back. Now I'm going to say, okay, then I want a queen. So I'm going to go and then see, okay, what's the probability of now receiving a queen? Well, there are 4 queens, okay, and the deck is still 52 because I've replaced my card. All right, so I have the same probability for getting a queen. And then finally, there is, I'm going to put it back in there, and then I'm going to try to see if I can get another queen. But that's, again, 4 out of 52. And these things, again, are all independent of each other. It doesn't really matter if you pulled up a king or a queen on the first or second try. It doesn't really impact your last one. But to get them all like this in a row, okay, so what we're going to have to do is we're going to have to multiply these probabilities, all right, as they're independent of each other. And you'll notice that it's actually really difficult to try to get those 3 in the order that you want. So now, okay, so for these ones, so 4 times 4 is 16. So this is going to be 4 to the 3. And then here you have 52 to the 3. So this becomes very low probability chance. Okay, so if I do this, so 4, and we are cubing it. All right, so that's that. And then we're going to be dividing by 52, and then we're cubing that. And this, okay, so in total, notice it's a very slim probability there. So answer, I'm going to multiply it by 100 to get it as percent. But you will notice that in order to do that, okay, so let's say this will be approximately, okay, our probability of getting exactly that, okay, if we wanted to do that. So that's the probability, okay, that you would have. Okay, so that's the second example. Now, your third example, what is the probability of tossing a coin 5 times and then getting heads on all 5 flips? So this is similar to the first one. So if you wanted to have, okay, so all 5 heads, so you're going to say heads and heads and heads and heads and heads. What's the probability of that in 5? So you're going to have 1/2, okay, is the probability on the first one. Okay, 1/2 on the second one, 1/2, 1/2, and 1/2. So this is basically 1/2. Okay, so this is because we're multiplying them. Again, they're all independent of each other. That would have been the probability. So it is 1, and then 2 to the 5 is, I guess it's 32. You can change that to a percent if you wanted to. All right, so that would have been the probability of number 3. Okay, so those are our first examples. See you on the future videos on these probabilities. I'll put up, I guess, a link to the kind of next video if you wanted to. You're going to be seeing it in the series. Okay, bye everybody.